Thanks for the introduction. Welcome everyone and good evening. Okay, this was not supposed to be the first slide. Sorry about that. Okay, so yeah. Okay, let me start. So today in my session, I'm going to introduce you to our next generation of our product platform, which is the ThunderID. So Geeks basically spoke what I wanted to introduce in the product. So we are doing a ground-up rewrite of our identity platform based out of Go. So I'll explain in my session. I'll talk you through what it is, what it can do, why we started building it, who's using it, and what it means for those who are using Identity Server as of now. But before going into the details, I just want to shift the focus that are shaping the current identity access management landscape in the industry. So starting with, and you guessed it, AI agents in production. Agentic AI has been, I'm sure like some of you folks are having a kind of hard time internally also because of AI agents going around and doing their own things within your organizations. So it sort of holds credentials, do API invocation. It sort of do things on their own, and it also sort of impersonate or act on behalf of you. And also, it's something that also need to be securely exposed to the consumers of it, right? So traditional identity representations do not accurately capture these requirements, and that representations are not sufficient to handle the challenges that are emerging with identity. So that's a key pillar that has started reshaping what identity looks like for the next couple of years. Post-quantum security, it's no longer a futuristic or scientific experiment, right? It's steadily evolving, and the threat associated with post-quantum security is very real. So harvest now, decrypt later, and there's trust now and forge later, kind of like more signature-related attacks are going to get very prominent when the post-quantum security or post-quantum computing is going to be widely available. So IAM sitting between these both aspects is going to be a key migration target for that. The third thing is the decentralized identity. So identity at the hands of the end user. So there's a lot of movements in the world, like especially in the EU. If you're familiar with the IDAS specifications that rolling out throughout the Europe. Nationwide adoption is there for the decentralized identity. So more privacy-preserving identity practices are emerging throughout the world. It's not just Europe. There's a lot of Asian, Middle East, as well as some state initiatives within the US also follow these decentralized identity principles. So even like wallets, Apple, Google wallets that we have in phone, it allows you to store these decentralized government IDs or mobile driving license in some shape or form. So, of course, some of these can be bolted on top of the existing identity implementations. But if you really want to make your identity solution future-proof, these things has to be incorporated into the foundation level, right? Identity server, surprisingly so, it has been around for 15 plus years. So there's a lot of use cases in varying complexities that WSO2 Identity Server has been solving throughout. So there are a lot of things that we have learned with the things that we did across a lot of you folks as well. So there's a couple of lessons that stood out that we have took into sort of practice or sort of grasped when we started rebuilding the identity core. So first thing that stand out is the integration happens at a flow or a journey level, not at the endpoint level. So true production identity is about getting user identity journeys like registration, login, and so on getting done. And it doesn't happen at the individual OAuth endpoints or SAML endpoints and so on, right? And customers don't want to often customize, they want to configure, right? So the default bundled product capabilities should be flexible enough so you can achieve variety of use cases without having to run custom code. So customization should be exception, not the default. The third point is what's run in product. So what's there in your runtime operations decides the cost of your identity operation. So the more things there are, more steps there are in your runtime path, it introduce additional cost, latency, as well as prone to the failures. So the leaner it is, the better. The fourth important thing is the shift how developers started shift in the developer interaction with the identity systems, right? So it started with SDKs and APIs, and it has evolved into more towards representing, like configuring identity journeys in a low-code, no-code manner, representing identity solutions in a declarative manner using GitOps, and most recently, integrating it with AI tools and your co-pilots through MCPs and also. So we sort of took these 4 learnings mainly, and along with that and the principles or the forces that I spoke about, we incorporated that into when we started planning our next iteration of the identity product. So these are the things that, on the right side, what you see is the things that we wanted to get it incorporated into the foundation, which we rather evolve on top of the existing capabilities. So agent identities native to the architecture. So I'll speak a bit about this in future slides, why it's important to get this natively adapted to the product's foundation rather than bolting into an existing infrastructure. Crypto agility, given the prominence of post-quantum computing, crypto agility baked into the product runtime is going to be important to support like incremental migration of your existing systems and keep the product ready for any future evolutions of in this angle. So small and faster headless runtimes, that is again something not easy to evolve, rather than it has to be built up. Then the modular foundation, so being able to have a modular architecture of the product is also going to be, has become one of the reasons that we wanted to do this ground up. This is ThunderID. These are the this is what we have. We call it ThunderID. This is coming from our Asgardio heritage, so Asgard, Thor, Thunder. So that nuance is there when we decided to name this product. So this is open by design, as like anything that we do in WSO2. Built for agents, ready for quantum era, lightweight and highly scalable. So this is open source under Apache 2.0 license, built from ground up using Go, which makes the product extremely lightweight and highly scalable. Next couple of slides, I'll talk about some of the foundational pillars that we have considered when we are building the ThunderID core. Agent native identity. So just pay some attention to the diagram I'm showing. So I spoke about bit like, and all the others spoke about this in a way like the multifaceted nature of agents. So it acts on its own, it acts on behalf of you, and it acts upon, right? So all these aspect of an agent is important. Representation, it's like representing based on the existing identity principles will not give us the benefit of or the flexibility we want to get support with the agent identity and access management requirements. So it's neither a service account or user account. So it should be much more in a foundational level. It should be much more to cater the dynamic changing nature of agent identity. So we are building a lot of things that is going to support the agent ID model at a foundational level. So again, like it goes without saying, it's represented as a distinct identity. So when you create an identity or a representation of agents, it provides the building blocks to support all these different facades of the agents, its own entity on behalf of and the resource capability. So cryptographically anchored identity or credentials is going to be a key thing, and a lot of industry standards are also evolving towards issuing cryptographically anchored identities for the agents. So delegation, authorization, or permission-bound scopes and time-bound scopes are going to be key things. And also factor in the consent requirements, and it's bounded by the user consent and bounded by the purposes and scopes and duration. Traceability, again, very important, being able to audit across the board on what agents do across your application infrastructure. So the foundation for that traceability comes from the identity system, the token it issues. So we embed information that helps the broader systems to identify who this agent, whether it's acting on its own or acting on behalf of someone else. Post-quantum security or post-quantum safety by design. Again, I talk about Harvest Now later on the encryption front, and Trust Now Forge later on the signature front. So I am sitting in between both of these things. It's going to be a key migration tool, a migration target, with the emergence of or like general availability of post-quantum computing. Along with that line, we have embedded a lot of capabilities that make the product flexible to support more these cryptographic requirements better. So it's crypto agile by design. All algorithms, key types, and token configurations are configurable, not baked in. And also supporting bring your own keys is also made available through the product architecture. By default, we will be supporting a whole lot of post-quantum algorithms, which is approved by NIST. So it will be enabled by default. So all the TLS level inbound, outbound communication is by default secure, post-quantum secure, and also we'll be using a standard allowed recommended algorithms for signature verification and encryption. Also, the hybrid mode is also pretty important because you can't technically, I mean, it's very difficult to do in a large ecosystem a big bang migration. So it has to, the classic algorithms and the post-quantum algorithms should coexist until you get all your infrastructure migrated to a post-quantum secure algorithm. So this hybrid mode is going to be supported. So when you are doing a TLS handshake or issuing a signature, both classic mode and hybrid mode will be considered there. So basically it's going to evolve. This is not a end state with regard to post-quantum security. It's just getting started. So the foundation is flexible in order to cater any new requirements around it. Decentralized identity, again, I mentioned there's a bigger movement across the world. So EIDAS is one of the most prominent applications of decentralized identity and verifiable credentials. And earlier this year, state of Utah sort of also released a framework for this decentralized ID. It's called State Endorsed Digital Identity. So basically, it enables citizens to bring in their identity representation via state endorsed. It's another different flavor of decentralized identity. So across the globe, different countries are moving more and more towards these decentralized identity things. So you may not be doing decentralized identity now, but when we are ready to adopt it, the stack will be ready to support your journey. So we are mainly anchoring towards the open ID standards when building these decentralized identity specifications. So ThunderID will be able to issue decentralized credentials, and also if you are building applications who want to consume these decentralized identities, it's very easy to integrate into your login registration journeys with the support of presentation layers. Basically, whatever emerging along the lines of the decentralized identity, we are going to head on and support. So this is going to be a key pillar that we focus on in terms of ThunderID's development. Lightweight, high performance runtime. So identity systems should be able to ship like any of the other systems in your stack, right? So you need to be able to containerize it, represent config as code, use GitHubs, and deploy through pipelines, right? So from ground up, from day one, we have brought in these cloud native principles into the ThunderID runtime. So because we started with the Go language framework, so it's very lightweight. So I'll go to the numbers at a later slide. Very little footprint, low memory and CPU consumptions are very favorable for high scale these cloud native deployments. It's capable of operating in a headless manner, so you can strip off all the UI components, be it admin or end user facing. It can operate purely in a API first headless manner. So all the SDKs, console, UIs, and end users UI sits on top of this headless runtime. So we also brought in special attention of being able to represent the identity solution as code. So these declarative resources supports representing your entire identity configurations and settings in a declarative manner, making it auditable, repeatable, reviewable, and promotable, right? So, and we allow importing, exporting the entire settings of your identity, the identity solution, and which enables GitOps. It makes it more GitOps friendly. The other aspect is the statelessness. By design, a lot of the operations within the identity product is stateless. So to start with access token, refresh token, they're self-contained. So the impact on the storage layer is very little. So if you're running identity at scale in millions of users authenticating in a short span of times, this is going to be a very cost-efficient way of doing high-scale identity. Immutable runtimes, this is again another capability that we are exposing through ThunderID. Basically, this allows you to run the product, stripping off all the control plane operations. So it only caters to the runtime traffic, and which makes it the product runtime much more lean, as well as reduce the attack surface around it. So that's the final foundation that we have brought in when we are building ThunderID. So let's have a quick glance at how the architecture looks like. It looks like a lot of boxes. So I'll go to the next slide to zoom out what the architecture brings in. So we sort of made it the product more modular. So we have a clean separation between what's the gateway runtime versus the control plane runtime. So the gateway consists of the protocol engine. This is the specification related stuff. The SAMLs, everything relies on this modularized protocol engine. Then there's a big emphasis on the flow engine or flow orchestration engine. Basically, we put a lot of effort to make all the identity journeys within the product highly orchestratable. So all the identity flows, user journeys revolves around this orchestration engine. So we brought in that support because, as I mentioned in my earlier slide, one of the paradigm shifts that we saw how developers interact with the identity system is like this orchestratability and the flexibility that brings in to build custom journeys for your end users. So runtime providers are like the supplementary sort of a core components that we support the flow orchestration engine. So this also exposes these atomic level identity operations, like maybe username, password login, or simply sending a SMS OTP in a more atomic manner. So if you want to orchestrate, do like a very custom level orchestration, you can rely on these atomic level runtime providers to build that experience at the client side. So we have clearly separated out the directory services, consent and authorization, and there's configuration service. So just go back. So this is what encompasses all these high-level modular architecture. So also some of these components we have made possible to run it as independent runtime. So gateway is there. So directory also, we have brought in the capability, we have the provisions to run it as independent directory. So if you want to do the user management, keeping everything else aside, that is possible. So platform services are the kernel of the ThunderID product. So all the logs, observability, caching, security, declarativeness, everything comes from these platform services. And also, this is more suited, the storage architecture is also more suited for runtime and ephemeral data versus more permanent data. So we support Redis databases and also for declarative representation of some of the configurations. So developer experience, as I mentioned, there are the way developers interact also have changed with the identity product. So for hands-on development, we have the standard framework SDKs. These are not just SDKs, that these SDKs are componentized. There are a lot of embeddable UI components in this SDK, so you don't have to code the entire experience within your application. All the implementations are protocol compliant and exposed to RESTful APIs. So generic flow engine, I spoke this about in my previous slide as well. So we bring in a very nice visual GUI no-code builder to orchestrate different customer user journeys. So I spoke about primitives as well. If you want to do the orchestration at the client side, these primitives are available. So we can't forget AI-assisted development this day and age. There's a lot of emphasis, like a lot of developers who are developing now utilize these tools. So we pack or built in an MCP server to the product runtime. So it's not something that you have to separate layer that runs outside of the product. It's baked into the product. This enables all the operations, configuration operations of the product as MCP tools, as well as we have brought in some instructional MCP tools where it helps the AI agents to figure out how to use our SDKs to embed the login registration capabilities to the products. Also, product will be shipped with a set of skills that agents can be readily used when they're interacting with the products and incorporating authentication and registration and other identity activities to the application. Okay, so benchmarks. This is one of the interesting sides I want to talk about. So we moved to Go-based runtimes. The benefits were very evident. Currently, with the set of capabilities we have now, it's about the entire runtime is about 35 MB. This is including the UI. So if you strip off the UI side of things, it's even like close to more 25 MB or something. So sub-second startup. So it's actually starts up below 1 second. It's close to like 400 or 500 milliseconds. The minimum baseline resource requirement is about 0.1 virtual CPUs and 50 MB. So on the left side to you, right side to you, you can see the performance aspect of the bare minimum resource requirements, right? So roughly like, you can see the specs. So 0.1 vCPUs, 50 MB of memory, and a concurrency of 10 requests simultaneously come into the system. So with this setup, the server is able to perform in these sub-second levels matrices. So this is essentially about close to about 30 transactions per second, if I'm not mistaken. This is with the bare minimum infrastructure. You can support this level of scale with a single runtime. Okay, so I have a few short, quick demos. I just want to highlight some of the awesome, nice things that we can do with ThunderID. So we have 3 scenarios that I'm going to cover. Scenario 1 is securing an application with ThunderID entirely using an agentic workflow. So basically what we are doing here is plugging in the native MCP server shipped with the product to Claude Code, and getting Claude build authentication and registration flows to the application through the utilization of our MCP capabilities. I'm going to quickly go to, okay. So this is a very short video, just try to follow up with me. So we start off with registering the MCP server in Cloud. So it will do MCP flow and register itself. So you have to authorize, and it will be ready to use different tools provided by the ThunderID server. So we ask them to integrate authentication first to the application. So it will go do a bunch of stuff and figure out all the tools and instructions related to incorporating login to this application. And at some point, it will go and register an application within ThunderID, so it can use these key secrets embedded into the application. So you can see the application is created. So it will use these key secrets of this application to embed it to the application and perform a login flow. So in this example, we are using a redirect-based login flow. In the next example, we'll look into embedding sign-up capabilities by using the native APIs without leveraging on the registration flows. So as you can see, all these things are orchestrated through the MCP tools. So you can see the native embedded experience of the registration as opposed to the redirect flow that we have shown in the previous example. So you can see the user is created. So it's very short. So all these samples and demos are available publicly and part of our documentation. So if you go to thunderid.dev, everything is currently available. So the next scenario, I'm going to show the GitOps, handling a GitOps scenario with the declarative capabilities of the product. So what we are going to do is we have the previous representation or the configuration of the ThunderID system, which was integrated with the Wayfinder sample application. So we are going to do some modifications to the login registration flow, and I'll show you how the representation can be seen with our export-import capability. So this is roughly the flow. So you have the local development environment, which already you're configuring your identity flows. Then through the export capabilities, we'll have the capability to represent the identity system in a declarative manner. You commit it to your GitOps repository, and which is tied with the CI/CD pipeline, and which eventually get synced to the production service. So the demo covers up to the exporting, like looking at the diff and identifying what are the changes and changes done in the orchestration flows. So again, try to follow up. Should play anytime now. Okay, so this is currently using the default authentication flows of ThunderID. So next you see, so this is the declarative representation of the entire system. So you can see different applications. So this is the sample applications configurations and different flows associated with it. So this is using default flow. Next, we'll go and do a improvement to the login flow by incorporating passkeys based login. So it's this is the wonderful drag and drop GUI we have with ThunderID. So we add passkeys now and we save it. Yeah, so it's a bit detailed representation. And we're going to, locally we can quickly test it out whether this is working. So as you can see, it's working as expected in the developer environment. Now we are going to export the config. So you can see this representation of configurations. So in a very GitOps friendly manner, you can easily see what are the changes. So you can review, audit, and commit and trigger the DevOps flow or the deployment pipeline for your deployment. Next one, again, what's a demo without doing agent ID. So I'm going to use ThunderID's built-in agent ID representation to secure interaction of an AI agent that we embed to the sample application. So we have a AI-driven concierge chat, sort of concierge experience with the sample. So you can see, okay, right. So so this is the chatbot. So we basically want, so you can see you have the first class representation of agents, and you can assign different roles, permissions to the agent. So here we first do like agent acting on behalf of its own. They don't need a user backing up for doing some of the operations. And then if you want more like a user-backed high privilege operations, they will prompt for user consent. So here the user is going to consent and give certain permissions for the purpose of that demo. So it can go ahead and do a booking in this case, but if you want to do anything more than that, the user does not have a privilege. So it's a very short video. So again, so basically this is wanted to showcase the ThunderID already have the native identity representation baked in. Where we are in few of our milestones. So currently, some of these requirements, so what's listed here is already available, and some of the things that I spoke previously are planned by the timeline of our GA release. So you can represent different types of identities, users, AI agents, specify schemas, credentials, and so on. We have a hierarchical organization unit model where you can represent different identity resources, be it users, roles, groups, applications, and so on. It all fits into this hierarchical model. So all the latest standards are supported O2, OIDC, and so on there. Flow engine is available with the capability to orchestrate login, registration, recovery, and step-up use cases. Fine-grained authorization and policy-based consent is also currently included with the product, along with white labeling and branding capabilities, and a whole set of SDKs and MCP capabilities are also available. So our initial milestone is targeted later in a couple of months, actually, this year, July. So 1.0 version of ThunderID will be available in July for general use. And even it's still open source, you can give it a spin with the current state of it. And the other milestone that we are working on is getting ThunderID donated to Open Wallet Foundation. So I spoke about decentralized ID being a key focus or a pillar of Thunder, and it fits Open Wallet Foundation. Even though it's named as Open Wallet Foundation, it does a lot more than wallets. It does a broader set of tools and specifications that are around decentralized ID. So ThunderID in a way becomes a natural fit that will be able to support more production grade use cases for the enterprise in a decentralized ecosystem or a verifiable credentials involved ecosystem. So these are the milestones that we have set for us. So some of the early adopters that we have, so we wanted to start off by having a community built around us. Some of the early adopters are like outside of WSO2. So the most interesting case, I would say, the MOSIP eSignet one. So MOSIP is, if you're not familiar with, it's a open source platform which helps governments to build foundational digital identity infrastructure. So basically, it's an entirely open source platform. So if a country wants to build a digital ID, you can use this platform. So this is currently adopted across close to 30 countries, like Philippines, Morocco, and a whole bunch of African countries are adopting, and some other Middle East and Asian countries are also adopting this eSignet. So a MOSIP system. So MOSIP has different modules. This eSignet is the authentication and eKYC module of the MOSIP ecosystem. So they are rebuilding their eSignet product, having ThunderID as the base. So this makes ThunderID supporting national level digital ID infrastructure scale. It's a very interesting use case. We'll very soon, we completed successfully our MVP, and very soon we are going to make this eSignet 2.0 generally available. It's a collaborative work with MOSIP team, and they're also contributing some of the code to our team. So other one is the LSF, Lanka Software Foundation. This is a not-for-profit foundation that works with Sri Lankan government, building different infrastructure for the government entities. So they are using ThunderID in a capacity of B2E, B2B use cases. Open Choreo you have heard. So we ship ThunderID by default to cater different STS requirements needed for the Open Choreo platform. And API platform and WSO2 agent platforms again uses ThunderID for their identity, STS, and agent ID requirements. So These are a few of these things. We sort of have a bit more things, but I sort of narrowed it down based on use cases. So interesting times ahead. Okay, so commercial offerings around ThunderID. So ThunderID is an open source product. So there will be a whole set of commercialized representations or like offerings built on top of ThunderID. So it's still going to be a 100% open source model. It's not an open core model. So Access Manager is sort of the all-in-one representation or all-in-one product built based on ThunderID. So it can secure any sort of identities, provide authentication, authorization, and all these things required end-to-end in an identity and access management system. So the STS is more focused towards the API security side of things, key management side of things. So that is another production or commercial offering that we are looking into, and also agent ID. So basically, current agent ID capabilities are the things that we embed into the identity server product, but we are planning to sort of build a dedicated runtime. So even if you have your own identity and access management system for AI identity piece only, you can use this agent ID thing. So the first two offerings will be available along the timelines of release of ThunderID 1.0, and towards early next year that we are going to launch agent ID capabilities as a commercial offering. So what's the great thing about this is we use the single source, it's the same OSS base to build it. It's not, each of these are not forks. We have like build the architecture in a so modularized way. So at the build time we can specify, how, what capabilities that should be baked into the product build. So it's one of the nicest thing about the way we have architected the product. It's probably one of the most important slides for those who are using WSO2 Identity Server. Again, so we spoke at the Geek spoke during the keynote. So it's going to, WSO2 Identity Server is going to continue. So we had the latest release last week, 7.3. And we have a healthy pipeline of roadmap items that we are targeting to deliver towards Q1 2027. It should be 2027, my bad. Sorry, so next year, early Q1, we are going to do a 7.4 release. So roadmap is there, so we'll keep supporting bringing in new releases. And of course, there will be no forced migration, obviously. So it's completely opt-in. But when it makes sense and when you're ready, you can choose into migrating or like switching to Access Manager or Thunder-based Access Manager. And when you're ready, we will be providing or supporting NIC required tools and assistant to make that switch as seamless as possible. And also, so we anticipate like coexistence of between both products in an environment. So ThunderID taking care of, or Access Manager taking care of a more modern, newer greenfield initiatives, while Identity Server catering the existing requirements. So yeah, this is an important message that I want to communicate before there's any FUD around it. So that is that. And